Hello guys, in this lecture we are going to discuss a problem of matrix chain multiplication and we will solve the problem using dynamic programming. Now the problem is to multiply the matrices, and we know that to multiply any two matrices there is a compatibility condition, means the number of columns in first matrix should be equal to number of rows in second matrix. If this is the case, then only we say that the matrix A1 and A2 are compatible. Then only we can multiply these two matrices. So we know that the process of matrix multiplication is, suppose we have a matrix of size 1 cross 4 and 4 cross 3, a matrix B. 1 cross 4 means there are 4 elements in first row and there are 4 elements in first column in this matrix B. Then the resulting matrix would be the order of 1 cross 3, and to fill the value, so we have 3 columns here, and to fill the values of first column we have to multiply these 4 elements with these 4 elements and add the multiplication. So to fill the one cell in the matrix C, we require 4 multiplication plus 4 additions. Okay. Similarly, for another cell, we require further multiplications. So the total number of multiplication required for to fill this to compute the resulting matrix C, the multiplication required is there are total 1 cross 3 elements, and for each element we require 4 multiplications. So this is 1 cross 4 cross 3. It means there are 12 multiplication required in order to compute this matrix C. So in matrix chain multiplication we need to multiply the matrices, and and secondly we have to take care about that matrices must be compatible. Okay. Now this is not exact the problem of matrix chain multiplication. The problem is how to multiply a chain of matrices so that the number of multiplication required is minimized. Here the meaning of chain of matrices means if we have given 2 or more than 2 matrices, then in what order we have to multiply those matrices so that the total number of matrix multiplication should be minimized. Let's explain this problem with an example. Suppose these are 3 matrices which are given of defined order, and we will multiply A1 and A2 first, then the resulting matrix would be multiplied by A3. So to multiply this A1 and A2 matrix, we require total 10 into 5 into 100 multiplications, and the resulting matrix is of order 10 to 5, and here we have A3 as 5 is to 50. So there are total 5000 scalar multiplication required for these operation A1 A2, and further to multiply the resulting arrays resulting matrix, suppose matrix resulting matrix C with A3, we require 10 into 50 into 5. It means we require around 2500 scalar multiplications. So the total multiplication required, if I use this orientation, then the total multiplication required is 7500. Now if I change the orientation and multiply the matrices like in this order A1 A2 A3, then the number of multiplication required to multiply A2 and A3 would be 100 into 50 into 5, that means it is 25,000 scalar multiplications, and then we have to multiply a1 with the resulting matrix here, and that would lead to 10 into the resulting order of this matrix is 100 into 50, so 10 into 50 into 100, it means 50,000 scalar multiplication. So the total multiplication required in this scenario is 75,000. You can see the difference between these two orientations. So the number of matrix multiplication required in this case is 10 times greater. So it is very necessary to find out the order in which the matrices must be multiplied. So the matrix chain multiplication problem says that for a given chain of matrices a1 to an, where we have n matrices with the defined dimensions of or order, suppose pi minus 1 to pi, the fully parenthesize the product a1 to n, we have to fully parenthesize this whole product in such a way that it will minimize the number of scalar multiplications. So this is all about the matrix chain multiplication problem. Now we will solve this problem using dynamic programming. So we will look how we can solve this problem using dynamic programming. So let's take an example. Suppose we are given 6 matrices with defined order. So we have a1 to a6 matrices, and that order which is defined is 30 into 35, 35 into 15, and so on. Now we will solve this problem by bottom up fashion, means we have to use the tabulation method, in which we have to find out the solution for subproblem which is a smaller size. So we start with the case where I have only one matrix, means suppose the name of this solution matrix is M, and the name for this matrix is S. Here we calculate the cost, and here we assign the solution of parenthesization. Okay, now suppose this matrix is, we start with the base case, we start with the subproblem of small size, and the subproblem is of small size when we have only one matrix. We do not need any parenthesization in case of one matrix. So we do not require any number of multiplication. So for itself, each matrix have cost 0, so we fill the diagonal elements as 0 in this matrix when the problem size is very small, only one matrix is there. Now the second diagonal here is when we have two matrices. So like if you want to multiply with a1 and a2, or a2 or a3, like that, or we can say that a1 to a4. So in this case, if we have two matrices, then we have to fill the value here. For second cell, we have to fill the value here. If you want to multiply matrix 1 with 2, means to fill the value, the case is where when you multiply a1 and a2, the number of matrix multiplications required is 30 into 15 into 35. These many number of multiplications are required in order to fill the values of a1 and 2. Okay, so I just fill the values here. So this is nothing but something 1500 750 multiplication. Okay, then we have to find out the value when you multiply the matrix a2 with a3. So the number of multiplications required are 35 into 5 into 15. So we can fill the values here. So it is comes out to be 2625. Similarly, for this it comes out to be 750. For this one it is 1000. For this one it is 5000. Okay, I hope you can understand. for this diagonal we have only one matrix like A1 only, so there is no multiplication required because it is a single matrix. I need not to multiply it with another matrix. When we have a problem of size 2 means we have two matrices. So when I multiply 1 with 2, 2 with 3, 3 with 4, 4 with 5 and 5 with 6 and 6 with 5 with 6. Okay, so these are the possible combinations in or possible compatible combinations, because the order is given in such a way that we can only find out these combination of two matrices or two subproblem. Then the number of multiplication required is like this. Now to when we move further and we want to find out the number of multiplication required when we have three matrices. So when we have matrices like A1, A2 and A3, how many possible combinations are there? How to fill the values for this one? Before proceeding to this case, let me fill the second matrix also. So what second matrix represents? It represents the actual parenthesization in the problem. So initially for the diagonal elements we do not need any parenthesization. So I just fill these values as 0. For the problem of size 2 we require the parenthesization and it is equal to the matrix size, because if we have two matrices you can divide the matrix from the first matrix itself. So I just write here 1, 2, 3, 4 and 5. Meaning is the meaning of this one is suppose we have a matrix A1 and A2, so you can do the parenthesization like this. So I just write this from 1th index I do the parenthesization. So this is from ith index I partition this matrix in two parts. Okay, so I just write the value of I here. I just write the value of I here. Okay, so this is how we fill the solution here. Now for the problem of size 3, when we have three matrices, how to fill the value here? So for the problem of size 3 or more, we have different orientations possible. So either I use this parenthesization or I use this parenthesization. So I will calculate the number of multiplication required in this parenthesization as well as the number of multiplication required in this parenthesization and pick that solution which have the minimum number of multiplication. So for this case, because for this M13 we have two solutions. For this solution I have already know the number of multiplication required for A1 and A2. So the number of multiplication required A1 and A2 is 1500, 750 plus the number of multiplication required of the resulting array. So the resulting array of A1 and A2 is 30 into 15 and the order of A3 is 15 into 5. So the number of multiplication required here is 30 into 5 into 15. So the overall computation of this matrix is so the total number of multiplication in this case is 1500, 750, which is the total number of scalar multiplication required for A1 and A2, and the resulting array with this A3 is 30 into 5 into 15. So the total number of multiplication required in this case is 18,000. If we use this second parenthesization, means A2 A3, we multiply A2 A3 first, then we will the resulting is multiplied by the A1. Then to multiply A2 and A3 we require 2625 multiplications plus the resulting matrix with A1 require 5250 multiplication. So total we have 7875 multiplication required. So in these two key scenarios, this one is minimum, so we have used this scenario in our case, because we want to find out the optimal number of multiplication which is minimized. So I just fill the value 7875 as a cost, and because we have to divide the array from the index I is equal to 1, so I just fill here value 1. So before the I is equal to 1 there is a one subpart, after the I is equal to 1 there is another subpart, so that's why I fill I is equal to 1 in the solution. Similarly, to find out the value for M24, there are two possible orientation. One is A2 A3 multiplied first, then we'll multiply with A4, or A3 A4 will be multiplied first, then we will multiply with A2. So in this first scenario, we require total 4375 multiplication. In second scenario we require 6000 multiplications. So because this is minimum, we pick this orientation and write here the number of multiplication required 4375. And because we divide from third index in our scenario, so I write here 3 in case of because at from third, because third means 2 3 will go in one part, and before more than 3 will go in other part. So I write here, I write here 3. Okay, now for next sequence I just write the values for the next level, so we can find out in a similar fashion. So we require 2500 multiplication for multiplying 3 to 5, and we require 3500 multiplications to multiply this one. And similarly we can fill the parenthesis, and this will also have a parenthesis as from 3, and this is when we have used the parenthesis as 5. Okay, now move further, and when we have a problem of size 1 4 means we have 4 matrices, so means we have to multiply A1 A2 A3 and A4. So to solve this problem, we have follow the same convention, means we divide the problem into this part. One is A with A2 3 in another part, or we can also have the combination when A1 and 2 is together with A3 and A4, or we can have A1 A2 A3 in one part and A4 is another part. So these are the three possible combinations which can be computed, and for each of these subproblems there are solution exist in our matrix tabulation method. So we can use this solution from the tabulation method and try to fill the values. Okay, so similarly we can find the further step. So I just fill the values for this subproblem. So in order to find the value of A2 A3 A4, so we already use the optimal solution for this subproblem. So when we have A2 A3 A4, the optimal number of multiplication required is 4375. So I directly use this number of multiplication 4375 here, and with this parenthesis, okay, plus the resulting matrix of this whole combination is, so when we have A2 A3 A4, it means A2 A3 A4, first we multiply these two matrices and the resulting order is 15 is 10, then we multiply it with A2 which have the order of 35 into 15, so the resulting order is 35 into 10. The order of matrix A1 is 30 into 35, so these two are compatible, and when these two are compatible we can directly calculate the number of scalar multiplication is 30 into 10 into 35. So the total number of multiplications is we have 30 into 10 into 35, which is equal to 1010500, and the resulting will equal to we have to add this 4375, and the value is 14875. Similarly, we can find out the number of multiplication required in these two scenarios, and the minimum value would be put inside this matrix. So this is the number of multiplication required, that is 14875. When we multiply a1 a2 and a3 a4, the number of multiplication required here is, for a1 a2 we can fetch from this matrix, for a3 a4 we can also fetch from this matrix. So you can see that we are not going to solve these problems again and again. We already have the solution for this matrix, we just fetch those solutions.